know how to make several different types of charts and graphs, let's talk about common mistakes when making graphs, or graphical misrepresentations of data. Sometimes they're not mistakes, sometimes they're intentional, but we want to make sure that we never do these things. So here we have 7 or 8 common methods for making a graph misleading, and an example of each type. So this first one, graphing or selecting an inappropriate statistic. So let's take a look. This picture is the bar graph of the top 5 nations for number of cars stolen in the year 2000. So why might this be an inappropriate statistic? If you look at the graph, the United States has 1,200,000, nearly 1,200,000 cars stolen every year, whereas the United Kingdom and all the countries in Europe and Japan have less than 500,000, but clearly there's a difference in the population. The population of the United States might be 5 times as large as the population of the United Kingdom or Italy, and so it makes sense then that the number of cars stolen might be 5 times as large. So this is just not an appropriate way to display the statistic. You might be able to investigate these relationships, but not in this way. So we would say because the population of USA is much larger, this is not an appropriate statistic. Instead of the number of cars, maybe you should have something like the rate of cars or the number of cars per capita, that type of thing. And then it might look a little bit more even. Okay, another common mistake or misrepresentation would be omitting the 0 on the relevance scale. So here on the left, you can see this is results by party, the percentage of Democrats who agree with some statement, Republicans and independents. And if you omit the 0 and you start your scale at 53, then it looks like 10 times as many Democrats agree with some statement than independents or Republicans. But if you adjust the scale by putting back in the 0 and starting from 0 instead of starting from 53, then in fact, it looks a lot closer than before. So this is a common misrepresentation that you will see, and you should be very careful if you're reading a magazine or watching television or reading a website. This is the type of thing you should look for before you just make an assumption about a graph. Sometimes people want to trick you. Another common misrepresentation might be manipulating the scale. So we talked about what if we leave out the 0, but then we also have how does it look if we change the scale. So we're starting at 0, we're not leaving out the 0, but we're looking at very small increments. Relative frequency of 0.05, 0.10, 0.15, 0.20, 0.25, and 0.30. So you can see it looks like there's quite a lot of variation here. Whereas if you look at it out of 1, so the total relative frequency, you can see that all of these guys are less than 20%. And there's not that much variation at all. So it's not that the picture on the left is inaccurate, but it's just that it leads your eye somewhere that might not actually tell the whole story. So again, it's your job when you're consuming news or other information to just look at these things and ask yourself. One other common tactic or possibly mistake would be to use a 2 or 3-dimensional area or volume to emphasize a 1-dimensional difference. So here we have NBA All-Star Game point leaders. And you have how many points does Shaquille O'Neal have in the All-Star Game versus Kobe Bryant versus Kevin Garnett versus Allen Iverson. But they're using these 3-dimensional pictures instead of just using like bars, which would be an appropriate way. So if you look, Shaq looks so huge here. And Shaq is great, so he deserves to be huge. But this is not an appropriate way to represent this, because if you then look at the actual numbers, 175 versus 149 versus 131, they're not that much different. So this is just not an appropriate way to display this information. Careless combination of categories in a bar graph, or biased distortment of images and embellishment. So let's look at careless combination. You have here, how often do we see red lights run? So how often does someone run a red light? And the categories are daily, a few times a week, seldom, or never. So never is a pretty well-defined category. It means 0. But seldom, we don't really know what that means, or a few times a week. That could mean different things to different people. So that's where we say careless combinations, daily, a few times a week. Well, maybe daily is a few times a week. It depends. So they're not well-defined categories. All right. One other common misrepresentation might be inaccuracy in the relative lengths. So here you have most World Series victories. New York Yankees 127, St. Louis Cardinals 52. New York, San Francisco Giants, 45. So 127 is more than twice a 52. 52 times 2 is 104. So 127 should be way out here. More than twice as long as 52. So this is just not giving the Yankees, I guess, enough credit for having won way more championships than the others. So maybe it fits better, and that's why they did this, because you can still clearly see that the Yankees have more, but if you compare the Cardinals and the Giants, these numbers are pretty close, the bars are pretty close. So if that's the case, then the Yankees bar should be twice as long as either of those other bars. So like I thought, there were only 7 of those that we came across, but you'll see more examples in your practice problems, in your homework, and these are just things to be on the lookout for to make yourself more informed, and definitely things that in this class and in all of your college classes, you don't want to make these mistakes, because these are the things that your teachers are very well aware of.